Now we're going to go ahead and start section 5.1 in your book. The first part of this is going over the natural log function. You probably did logs in Algebra 2 or maybe in physics when you did log base 10. We're going to be doing natural log, which is log base E. And we'll get into that more kind of as we go through the section and the rest of the chapter as we go through this. But for us to understand, the definition of a natural log function is the integral from 1 to x of 1 over t dt, as long as x is greater than 0. So when we take a look at this, it's the ln button, or log natural, or natural log button in your calculator. It's the ln button. So if you just go to your calculator, hit y equals, and graph ln of x, your graph will somewhat look like this, right? Your screen's going to obviously show more when you hit zoom 6 and put it in a 10 by 10 window. But that's what the function is. So in this chapter, you're going to be using a lot of the ln button and the second ln button, which is the e to the x that we're going to get to when we do the exponential portion of this. So, Theorem 5.1, just properties of natural logs. So natural logs, the domain you can see from the graph, is going to be 0 to infinity, or all positive real numbers, and its range goes from negative infinity. So the output can be positive or negative, but the only inputs we're allowed are 0 to up to and not including infinity. Okay? Then the function is continuous, and it's 1 to 1, and it's always going to be increasing, and we consider the graph to be concave downward the entire time before we do any other adjustments to it. Alright? What you're going to focus on a lot is Theorem 5.2, the properties of logs. If you understood the properties with exponents in algebra, as long as they had the same base, you either, if we were multiplying, we added exponents, we were dividing, we subtracted exponents, those sort of things. Same properties here, pretty much the same for logs. So, some that we need to know and that we're going to use a lot. The natural log of 1 is 0. If I have the natural log of a times b, some sort of function a times b, I can break that up and rewrite that as the natural log of a plus the natural log of b. If I have the natural log of a to a power, it's very important where that power is. It's on the a value that's in there, not on the natural log. Okay, so that exponent can come down in front, and we can rewrite it as n natural log of a. So every time I see ln, I just say natural log. That's kind of the nomenclature, how we go through it. I'm not going to say ln a, ln b. It just doesn't sound right, and you could be thinking ln n are variables when ln is indeed natural log. Alright, if we have natural log of a divided by b, we're going to rewrite that as natural log of a minus natural log of b. And then up there, since e is the base of natural log, if we take natural log of e, we get 1. So those are properties that you're going to need to know. So if we're going to expand or simplify logs, or we're going to need to be able to rewrite them before we take the derivative or antiderivative in a little bit. So more or less in this first section, we're going to be rewriting logs, and we're going to be taking the derivative of logs. Then we get into section 5.2, we'll take the antiderivative and go through some examples there. Okay, so looking at example 1, we want to expand logarithms. What we're really going to do here is just apply all the different rules that we just talked through. So example 1, part A, say we have natural log of 10 divided by 9. We would rewrite that as natural log of 10 minus natural log of 9. If in part B we have natural log, the square root of the quantity of 3x plus 2, okay, the first step that I would do is rewrite that radical sign as a 1/2. Now that 1/2 is a power, so I can rewrite that as 1/2 natural log of 3x plus 2. Notice there's nothing we can do with that 3x plus 2 because it is its own quantity. It's not being multiplied. So when we apply these rules, they're going to apply with an exponent, they're going to apply with multiplication and division. We will not be able to combine addition and subtraction and undo those unless there's a natural log in front. So if there's just a quantity like this binomial in part B, that's as simple as it's going to get. Alright, let's take a look at part C. There's two parts here. Okay, there's first we're going to undo the division, and then we'll undo the multiplication. So notice we have natural log of 6x divided by 5. So we can rewrite that as natural log of 6x minus natural log of 5. And then we can rewrite that natural log of 6x as natural log of 6 plus natural log of x minus 5. So there's how we can expand. Expand means we're making it longer. So first couple of problems on your homework, you might have to expand to do that. Part D is important. I know it looks like a lot of steps, but we're going to have to do that to simplify to take derivatives and antiderivatives later on. So if we take a look at this, part D, we have the natural log of x squared plus 3 quantity squared divided by x cubed times the square root of x squared plus 1. Pretty complicated function. When we break it down and start rewriting it, it becomes much simpler. So the first thing that we want to undo is the division. So I'm going to rewrite that as the natural log of x squared plus 3 quantity squared minus the natural log of x cubed times the square root of x squared plus 1. Then what I'm going to do is on that first one I'm going to bring that exponent, that 2 in front. So I'm undoing that power rule. So I'm going to rewrite that as 2 natural log of x squared plus 3. On the right hand side, notice that's a product rule, that there's x cubed times x squared plus 1. So I can break that into two different natural logs because they're being multiplied. So I'm going to rewrite that as natural log of x cubed plus natural log of the square root of x squared plus 1. That first term I'm going to leave alone for a little bit. I'm going to keep working on that stuff on the right hand side. I'm going to bring the power down on that first one and rewrite it as 3 natural log of x. Plus I'm going to take that radical and write it as a 1/2. So I'm going to end up with natural log of x squared plus 1 to the 1/2. And then down on that next step, I'm going to leave the first part alone. I'm going to leave that little second part alone. And then I'm going to bring that 1/2, that power rule, down in front. So I'm going to end up with 1/2 natural log of x squared plus 1 on the right hand side. So the last thing is really I need to distribute that negative through. So the final expansion on this problem would be me rewriting this as 2 natural log of x squared plus 3 minus 3 natural log minus 1/2 natural log of x squared plus 1. Alright, so just going through some basic ones here. Let's do a few more examples here. Example 2, part A, we have natural log of x over 4. So when we want to expand that, we're going to use Theorem 5.2, Rule 4. So that's natural log of x minus natural log of 4. So we've expanded that. Let's look at the next one. We have natural log of the square root of x to the 5th. You need to rewrite that, that square root. And since there's a 5 on the x, that's going to be in the numerator. So we're going to take natural log of x to the 5/2, and we're going to rewrite that by bringing that exponent down in front. So we're going to get 5/2 natural log of x. So we're using Rule 3 there on Section 5.2. Part C, okay, we have the natural log of x times y times z. Those are all in the parentheses, so we can expand that out using Rule 2. That becomes the natural log of x plus the natural log of y plus the natural log of z. Okay, so however many terms there we can add in between. Okay, example D, we did one similar to this early on in the video here. We have the natural log of xy divided by z. Undo the division first, so we rewrite that as natural log of xy minus natural log of z, and then that xy is multiplication, so we can undo that with addition. So we end up with natural log of x plus natural log of y minus natural log of z. Okay. Part E, we have the natural log of 1 divided by e. So since that's division, I can rewrite that as subtraction. That becomes the natural log of 1 minus the natural log of e. You can use your calculator to get those values. The natural log of 1 is 0. The natural log of e is 1. So 0 minus 1 is negative 1. Those should be ones that you're going to pretty much memorize and use a lot. Kind of like doing the quadrantals with trig functions. Let's look at F. We have the natural log of z times the quantity of z minus 1 squared. First thing we need to undo there is the multiplication piece. Don't bring that power down first because that power is only on the quantity of z minus 1. It's not on the z. So we have to undo the multiplication first. So we're going to rewrite this as natural log of z plus natural log of the quantity z minus 1 squared. Now that we have those separated, I can bring that exponent of 2 down in front. So we're left with natural log of z plus 2 natural log of z minus 1. Next, part G. natural log of the square root of that entire function. So the x minus 1 over x is all square rooted. So now I have to rewrite that as natural log of x minus 1 over x all to the 1/2. This is a case where I bring the 1/2 down first. So the 1/2 comes in front, so I'm going to get 1/2 natural log of x minus 1 divided by x. Now I undo the division with subtraction, but notice that 1/2 stays in front and has to multiply by each term. So it's going to be 1/2 times natural log of the quantity x minus 1 minus natural log of x. So that'll be your final solution there. Okay. Looking at example H, we're going to have the natural log of 3e squared, and we're going to go through the solution here. So those are multiplication, so we'll rewrite this as natural log of 3 plus natural log of e squared, and then the second part is bringing that exponent down. So we're going to end up with natural log of 3 plus 2 natural log of e. Natural log of e is 1, so 2 times 1 is 2. So we're going to have the natural log of 3 plus 2, which is 3.0986. So that's using properties of logs there. We're going to talk about e for a second, and then we're going to get into some more examples in the next video here. So to get to e in your calculator, you have to hit second and natural log. That's going to give you e to some exponent, and then you start plugging in the exponent. So if you've ever wondered what that e is, it's 2.7. But for us, if you just use e to the first in your calculator, it's going to give you this long decimal that I've written down there. E is an irrational number just like pi, so it's going to go on forever. So for us, the definition of e, the natural log of e is 1 to e of 1 over t dt equals 1. Let's just go through a few examples here using your calculator so that you know how to do this. Just hit natural log of 2. So hit ln on your calculator, hit 2, hit enter. You should roughly get 0.693. So there's different problems here. You should be able to use your calculator and get these same values. Natural log of 32 is 3.466. Natural log of 0.1 is negative 2.303. Natural log of 0, however, does not exist. Alright, we'll talk about that one a little later on. It's an error in your calculator. So remember, the domain of natural log is 0 to infinity, but they're both in parentheses, which means we do not include that value. The graph tends to go to negative infinity there, but the natural log of 0 does not exist. Alright, and another one we've already kind of talked about that you need to know, the natural log of 1. If you use your calculator, you will get 0. Alright, next video we're going to learn actually how to take the derivative of a natural log function. Very important. I've got to get back into the case of doing some u substitution and those sort of things. Like I said, any of that first part, that's just learning some properties of logs, being able to rewrite logs and expand them or condense them. I'll do some examples at the end of the video that go the other way, give you a really long expanded log term, and we'll shrink it down into one term. But next video for section 5.1 is going to be going over derivatives of natural logs.